Hello, everyone. Good evening. This is Naveen. Welcome to Applied Gen AI workshop today. Let me see if I can share my screen. Give me one sec. Okay. So hopefully you can see my screen. Just type it in the chat window if you can, real quick. Yes or no. Can you guys hear me? Okay. Thanks, Manoj. All right. Let's get started. Let me adjust this a little bit. All right. Cool. So just making sure my setup is right. Give me one sec. Yeah, Manoj, go ahead. You can. Oh, chat is disabled. Okay. So maybe type your question in the Q&A, Manoj. That helps. See, you raised a hand. If you have a question, just type it in the Q&A. Cool. So let's get started. I think we have a quorum. We have a good number of people. So let's get started. First of all, thanks for joining the Applied Gen AI workshop. So today we'll try to build a Gen AI application called LectureBot. We'll discuss about what that is. But before doing that, let me give you a quick, brief agenda. So let me see if I can change the view. Oops. Okay. All right. Hopefully that is better. Yeah. So quick overview about me. I lead the AI and engineering team at Vouched. And prior to that, I worked as head of applied science and engineering in Amazon Private Brands, private brand discovery. I live in Seattle, have a master's in CS. Overall, I have about 17 years of experience in various ML roles, experiences in natural language processing, recommendations, ads, and more recently, a lot of work in the computer vision space, face recognition, object detection, segmentation, semantic segmentation. So I have my LinkedIn profile over there as well, if you want to. So brief agenda for today. So we'll quickly go over the Gen AI tech stack. And after that, I'll introduce you to the problem statement for the demo application that we are going to build. And then I'll walk through the RAG architecture and why that is needed for our demo app. Finally, I will walk through how I put together this demo app. All of you can follow along if you want by just running the code, but that's not mandatory. In the end, I will spend some time to answer Q&A, and I will also give a very quick 5-minute overview about the IK program, about Gen AI. It's not a sales pitch, but I just want to give you some salient aspects of the program. So that will be a plan for today. Also, just to set the expectations, I will pause every few minutes to answer any questions. So if you have any questions, just type it in the Q&A. I'll take a look once in a while and answer the questions. And I'll also ask questions throughout the class or throughout the webinar. If you know the answers or if you want to participate, just type in your answers. You can just type in the Q&A for now. Let me see if I can enable chat. Give me 1 sec. I am not sure if I am able to enable. Okay, let me see. Okay, I'm not seeing that option to be able to enable it. Panelist attendees. Oh, yeah, I can with hosts and panelists, or actually, yeah. So yeah, try it. You should be able to chat now. Let me know if you can't. You can type into the chat something. So yeah, see if you can, chat. Yeah, cool. Awesome. All right. So that's the brief agenda for today. So logistics wise, if you have questions, ask in the Q&A. If I ask you questions or you want to participate, just type your answers in the chat. So that's the main distinction. So yeah, any questions on the agenda before we get started? Awesome. So maybe a very quick thing before we start. I'd like to know who my audience is. So if you can type in your name, your title, and where you live, I think that would be really helpful for me as I structure this webinar. Just type it into the chat. Awesome. A lot of varied backgrounds and across the US. I'm seeing people from, East Coast, West Coast, and Central. Awesome. Thanks for sharing. Yeah, keep them coming. I'll keep an eye. So just getting started. So I'll quickly give you a high-level overview of what we are trying to build today. Let me reset the Zoom. So imagine you just attended some lecture, on a topic, and you have the recording for that lecture. Let's say you went to an IK interview Kickstart lecture on, let's say, neural networks or something else. And now you have the lecture and it's time to review the lecture. Or you missed the lecture and you have lecture video, so you're trying to understand what was covered in the lecture, and you're pressed on time. So maybe if there is a way to just interact with the lecture, to ask questions and learn in a chatbot style of way, wouldn't that be very useful? So it would provide a very effective way to learn, wouldn't it? So that's what we'll try to build. We want to take a video as an input and provide a chatbot query interface to it. We will be building this today. So two caveats. One, we won't be building the front-end interface. We'll be showing just from a back-end perspective how this works, and be able to build all the back-end engines behind it, so that you can still get the answers from the queries. And two, since the video transcription is already available for a lot of our videos, we'll just directly use the transcript, but I'll show you also what libraries you can use to transcribe videos on the fly. So those are two caveats, but I also want to set up the expectation that you don't need to know any of these concepts, and that I will be covering them throughout the presentation. So you can come with no knowledge in the space and still be able to follow this. Now, before we jump in and move forward, can you think of any other relatable use cases, with this kind of flow, that can be helpful in your day-to-day? You can type in your thoughts and answers in the chat window. Team meeting, minutes chatbot, yeah. Chat with PDF, yeah. Yeah, fairly similar, yes. Yeah, right on. A lot of good thoughts there. So yeah, very similar use cases. So I want to give a quick overview about Gen AI, and how that plays, where that falls in the overall ecosystem of deep learning. So overall, if you look at deep learning, so Gen AI is very famous these days, right? So just to understand how that fits into the overall DL ecosystem, broadly DL can be divided, deep learning can be divided into two major groups. Like is the Zoom still not good? Can you see okay? I'm getting some feedback that the Zoom can be increased. I just want to check. Okay. All right. Let me know in case, if you're seeing issues. For some reason, my whiteboard is acting finicky today. So that's why I'm trying to resume every time when I change the slide. But yeah, so deep learning, at a high level can be divided into, two major branches: predictive branch and the generative branch. So all the, most of the DL models that you might have been exposed to in your day-to-day or at work are either classification or regression tasks. So you're either predicting something like a classification model or regression model. A lot of models related to recommendation systems, images, object detection. All of those fall in that category of prediction. The generative AI side of things is more about, instead of predicting, it's more about generating a new data based on, some existing data or just from noise. So the generative models are in the space of, text, image, other kinds of data. I only put text and image here because those are, very popular. Um, so um, let me see, I'm getting some feedback here. Is it possible to overlay my video like here, you mean? Okay. Yeah. Anyways, let me know if you need any changes. So, and why did Gen AI become so popular these days? Is one, I know GPUs have become more powerful, and there are more advances in the GPUs and compute acceleration, and all pervasive, allowing us to take advantage of it to create much more complex models needed for on the generative side of things. So for the generative models are much more complex and take a lot of time to converge. So because of the increase in GPU capacities, that kind of helped with building these models. And also there is more accelerated computing at disposal. Like even from not hardware, even from a software perspective, like there are so many algorithmic advances in the last few years, like transformers, encoder, decoder architecture, stable diffusion. Can you think of like, some interesting models that came out in the Gen AI space in the recent, let's say 1 year? Anything that comes to mind? Mamba. Okay. Segment anything? Yeah, that's a big one. Yeah, stable diffusion is a kind of model that is based on diffusion framework where um, it's a diffusion models are kind of models where they kind of build by adding noise at each layer and removing noise to get to the final image. So it's very popular to generate different kinds of images, like like a person riding in horse in the space, things like that. So those were like um, built through developed through stable diffusion. Um, it's gained a lot of popularity in the recent past. Um, so like you might have heard of models like CLIP, which is contrastive language image pre-training. So it kind of combines text and images. So you can write your prompts, and the model creates an image based on those prompts. So that's another generative model that has become very popular. Um, um, Obviously, OpenAI's GPT models are generative. So a lot of popular models that you guys use on a daily basis um, are based on generative AI. Yeah, Compose AI. Cool. So I think this is a animation slide. So some of the areas where Gen AI can play a role, right? Um, so if you see like different areas, you might have experienced some of these, like question answering, which is something what we are trying to build now, or language understanding, summarization, um, or code help, code completion. So on like there are so many use cases where this can generative AI can help. Can you think of like some use cases where where generative AI has helped you, or that it can help? Anything on the image side, like where like uh, let's say if generative AI can generate realistic images, where can that help, for example? Can you think of some use cases? Yeah, yeah, marketing, good one. Yeah, so any creative side, like you can use generative AI. You can also use generative AI to generate images to augment your training data, to train other models. Um, I think I've seen something else here, like drug discovery or something, which is kind of true. Like I think generative AI plays a role in kind of understanding um, uh, uh, gene chains, and uh, generating new forms of DNA chains to understand if certain chains are more susceptible to certain drug kinds. So a lot of application of Gen AI across different fields. Um, so I want to give a quick high-level overview of various technologies involved in the Gen AI space, just to get us grounded. Kind of, you know, um, and Gen AI is evolving so fast, right? So this is not a comprehensive list, but it does capture salient technologies used in today's Gen AI space. Overall, the stack can be, divided into these major buckets. Starting from the bottom, if you look at the hardware layer, and moving towards the top, towards platforms and foundational models, databases, orchestration, runtime. Front-end technology is not so important, uh, but also LLM ops and ML ops space, once you productionalize it. So at the bottom of the stack, you know, um, or compute hardware like chips from NVIDIA. NVIDIA is kind of dominating the space with their GPUs, A100s, H100s, H200s, which are coming up based on Blackwell architecture, and hardware accelerators required for model training and inference. Um, so in the recent years, like the raw computing power, as I said, has increased, and the processing efficiency is kind of doubling every 18 months in the recent past. And obviously NVIDIA is the leader in that space, but a lot of other products like AMD and Intel are kind of playing catch up. Um, and also, if you might have heard, OpenAI is trying to build a consortium to build hardware um, um, with like 1 trillion budget. So it's still in the works, but that's something in the works. So there are like very specialized processors that are developed, like GPUs other than GPUs, which are more generic. Google introduced like TPUs, tensor processing units, that are specifically designed to handle large-scale ML deployment. So all of these are really important for handling Gen AI workloads. And then coming to the infra cloud platform level. So behind the scenes, all of these infrastructure vendors play a pivotal role in the Gen AI solutions. Like these include like cloud hyperscalers like Amazon AWS, Azure, GCP. They not only provide the storage and computational resources required in this analyzing these massive amounts of data, but also provide like full stack tools like models, hosted models for building Gen AI applications. So currently, the offerings from various providers are fairly similar, but some are slightly advanced in certain areas. So if you have experience like AWS, Bedrock, they're kind of very up to date in terms of hosting open source models. Like Llama 3, I think, is getting hosted on AWS pretty soon, which was released last week or the week ago. GCP has similar thing, like they have a GenAI studio where there's several of the open source models are hosted. And the next big bucket is the foundational models. So foundational models are models that are built on a lot of open source data crawling the web, right? So instead of everyone building a foundational model from scratch, most enterprises will choose an existing foundational model that suits their needs. There are open source options such as Falcon or Llama 2, backed by Facebook, as well as commercial closed source models like OpenAI or Anthropic, and within the open source models there are even within open source, like there are two different kinds, like open weights model and open source. Do you know what the difference between open weights and open source? Just curious if anybody experienced. So open weights is, let's say some open source provider built a model. They kind of give the entire model, but don't provide access to the weights of the model. So you can take that model and fine tune it or repurpose it. So that's not possible. For example, Llama 2 is not, or Llama is not open weights model. You can just take the model and use it. Versus open source model is, it's fully fine tunable, wherein there is granular access to all the weights and the internal APIs of the model. So you can take the model, fine tune it, customize it to your own purpose, and then productionize it. So there is a bit of distinction when you're choosing what kind of open source models you want to use for your use case. But there are several options out there at the moment. And then the next major bucket in the GenAI tech stack is the databases. A lot of GenAI workflows include working with vectors. Vectors are nothing but think of coordinates, like GPS coordinates, right? Like you have longitude and latitude. Like that, vectors are like n-dimensional. So you have a vector size of 512 or 768, depending on the model dimensions. So these vectors are float points, and a vector of numbers, and that's how the languages or words in the languages are represented, or images are represented, and that's how a lot of calculations of similarity, dissimilarity are calculated. So in order to store and retrieve these vectors, is a new kind of databases where we're born. So these are called vector databases. There are a lot of providers there, like Pinecone or LansDB, Quadrant. We're using Quadrant for our demo here. But yeah, there are some open source options out there, as well as commercial options in the vector DB space. And then from a runtime perspective, so essentially runtime is a suite of tools and functionalities, right, that are critical for leveraging all these models in various applications. So it provides easy access to all these GenAI specific functions and workloads, like retrieval, chunking, prompting. So Llama Index is one of those, one of the frameworks that you can use for runtime. Langchain is pretty famous in the space. It's widely used. So it provides a more general purpose framework, flexible enough to, pave the way for a broad spectrum of LLM powered applications. While Llama Index is more focused on, very specific aspect of LLMs, like indexing and enhancing the performance of them. So runtimes are equally important part of building a Gen AI workflow. And then LLM ops. So several tools have emerged in the LLM ops space. There are point solutions for experimentation, deployment, monitoring, observability, prompt engineering, governance, as well as end-to-end LLM ops, like tools like ML ops, ML flow, that play a major role here. Once you put the whole application in production, how do you monitor, evolve the application? So that's the high-level overview of the entire Gen AI tech stack. I want to give that brief overview before we get into the build of the actual demo application. Cool. So let's go ahead and understand what we are trying to build and what are the core aspects. We've seen this slide before. So again, the core idea is to build a application that can transcribe videos, and we can create a chatbot on those transcriptions, so that it's an effective way to learn from the lecture rather than watching the entire lecture. Now, before we move on, can you think of, like, let's say you have this built, and let's say this is a lecture, like, based on neural architecture. So it's one of the lecture I was teaching earlier today. And let's say you have this lecture and you are able to transcribe and build this application. What are some likely questions you would want to ask from this lecture? Summary of key points. Yes, that's a good one. I'll start there. Quick demo. Okay. Cool. Yeah, I think those are all good prompts. So we can ask for summary of key points or key topics. Yeah, it should be personalized to everyone, but just want to hear your thoughts. Like, how would you, what kind of questions you would want to ask? So yeah, so I would ask some prompts like, what are the key topics in the lecture, or tell me more about topic XYZ. Or provide a summarized version of the lecture in less than 3 paragraphs. So yeah, so that's how I would interact with this lecture if I were to do it. Essentially, the lecture bot should analyze and summarize the entire class video from this private source, right? This is a private lecture, and can enable learners to grasp the material better using these custom kind of prompts. So with that knowledge, so now that we know what to build and why we are building, let's brainstorm a little bit on how to build this. And maybe we can whiteboard this a little bit. Maybe think of the flow here. So we have, a video. Oops. And we're trying to get to a chatbot. So what's in between? Maybe think of like, what are different components that you want to build here? Could we provide default options for the user to select to ask the lecture bot? You mean like a set of default prompts? I think so. Yeah, we can set up the prompts that way. Yeah. So just want to brainstorm on this a little bit. So how are we? I just want to see, what are the different things we need to build at a high level to get from here to here. Any thoughts? What are the different components that we need to build? So we'll start with a video, right? So we need something to transcribe the video. And then once the transcription is created, we need, another component to clean the transcription and, chunk and summarize it. And maybe once we have the chunking and summarization, maybe we want to store those chunks into a data store, like a vector store. And then we probably need, once we store everything, when the user asks questions, we probably need a retriever to search. So we need some efficient search. And then fortify the prompt with retrieved information. And return the result. So at a high level, these are all the functions that we are trying to achieve to get from like a video to chatbot. And we'll see how we can create those. Did I miss anything? Anything else we need to do here? Cool. So maybe we'll start with some naive approaches. So maybe one way is to take a generic LLM, like something that's trained on a lot of foundational data or public data, and just build a chatbot. But this one doesn't have any private data like the one from our lecture. So it's too generic. It doesn't have any private data, so it won't work for our use case. So it's too naive. Maybe it will provide some generic information about the topics from the lecture, but it won't give like very specific topics that were discussed in the lecture. So it may not work really well for our use case. Maybe another approach is to take a generic LLM and probably fine tune that LLM using our data. Private data in this case is the lecture data. And that involves like using like techniques like RLHF to fine tune and customize. but that is a very expensive process, and it also needs a lot of data. So so it may not also work really well because one, we don't have a lot of data. It's just a few lectures, and two, it's also very expensive to take an LLM with lots of parameters and fine tune it. So do you know, for example, if we were to fine tune like a chat GPT class model, do you know how many parameters GPT-4 has? Billions. It's actually GPT-4 is a combination of 4 models. And each model has about 250 million parameters. So it's about a little over trillion parameters. So it's a very big model. In comparison, GPT-3 has I think 175 billion parameters. So it's huge. And in order to even load that kind of model into memory and train it, you need very large scale infrastructure. So, and we'll see why even prompting and summarizing is takes a lot of compute, and you need very efficient workflows to be able to do that. We'll see in a little bit, but that's the scale we're dealing with. And also, fine-tuned models could still make things up. Fine-tuned models, even if you are able to fine-tune, because they can hallucinate, and they can emit, wrong answers. There is there is still there is a lot of further optimization that needs to be done using techniques like DPO, direct optimization, or RLHF to align the fine-tuned model to human performance. So for those reasons, fine-tuning is not a really viable approach for things like this. So what if we don't need to train a custom model, but we can essentially get away with taking a generic LLM, which is trained on public data, and just use private data at runtime to provide to it as context. So our chatbot only gets to look at the private data to give us answers. So what if we can design that sort of workflow? Then it could satisfy all of our needs. One, our data stays private. Two, we don't have to take a generic LLM and fine tune it. And so you're kind of solving both the use cases, and be able to get to what you're trying to achieve. So so for that, this workflow is called RAG, Retrieval Augmented Generation. And we'll see how that works, and how we can build it. In general, a RAG workflow looks like this, rather than the diagram I put together earlier. So it has components that we discussed a little bit earlier. So starting from here, so all the data preparation of private data is here. So private data is cleaned up, chunked, created into embeddings, and then the embeddings are essentially the vectors, and these are then stored into the vector database. And once this is done at runtime, the user queries with certain query, which is also converted to embeddings, and all the relevant chunks related to that query are retrieved. So that's why the name retrieval. And these retrieved chunks and documents are provided within the prompt as context for the LLM plus the query to give the final response. So that's how the typical workflow works in a RAG. where one is there is a data preparation and data generation pipeline, which prepares the data and stores the data in the vector database. And then there is a retrieval pipeline, which retrieves the right documents needed to answer a given question. Cool. So with this knowledge, now let's go ahead and move on to build our demo app. Let me see, there are some questions. So if you give your embedded data to LLM, is your data safe? It seems you are giving the data to LLM in the end. So that's a very good question. So you can control how you're using the LLM. In this case, I'm using a privately stored LLM. I'll show you what I'm using in a little bit. So you can fully control, if the data stays in your ecosystem, or if you're calling some other open source API or paid API like OpenAI's APIs, and sending the data to their API. So in that case, there is some data leakage externally. So if your use case needs some sort of confidential data, or and you want to keep it within your ecosystem, then there are ways to do that. There are like the application we build is completely within our ecosystem. Hemil Kumar, can you elaborate embedding? So yeah, so as I said, so embeddings are nothing but a bunch of vectors, so let's say we have a chunk of today I'm teaching, today I'm teaching NN class. Let's say that is a sentence that is being converted into this embedding. So it's a bunch of numbers, like I think most of them are 512 or 728. Sorry, 758. And these are like float point numbers, like 0.1133, 0.5566. So this is a representation of this sentence in numbers. And the way this is done is by passing this sentence through a transformer that can understand the sentence and convert into a set of numbers which represent this sentence. So these numbers are created in such a way that sentences of similar type are close to each other in terms of proximity of these numbers, and sentences of dissimilar type are far from each other. The transformers, they understand the semantic aspect of the sentence and create these numbers or embeddings in such a way that these numbers are closer for similar sentences and farther away for dissimilar sentences. Hopefully that helps. Cool. So let's move on. So again, with this knowledge, so let's move on to build our app. For the app, these are the different tools and technologies I'll be using. Python 3.9 is the version I'm using. You can use any editor. VS Code is the one I'm using. I'm using a local model. My MVP MacBook Pro, even though it is fairly advanced, it's still not able to run in a good amount of time. So I'm using an AWS EC2 instance for compute. I'm using Langchain framework, which we looked at earlier, for orchestration. And for the LLM, I'm using a local LLM. I downloaded Llama 2, 13 billion model, and I'm using it in the local environment. For the vector store, I'm using Quadrant. And to create embeddings, I'm using sentence transformers. specific version is OLMPNet base v2. It's pretty famous for creating embeddings of sentences. How much memory is required for this particular one? I think to run it reasonably in reasonable amount of time, I'm using a G4DN 12x large. I think that comes with 32 gigs memory and 4 GPU cores, and I think 16 virtual CPU cores. So that's the EC2 I'm using for this particular. Circon, how do quadrant, pinecone, and fast compare? Bit offshoot topic. Again, fairly similar. Fairly similar products. Pinecone is kind of the leader these days. Fast started as as approximate nearest neighbor search, developed by Facebook, and it works really well for ANN kind of applications. But Pinecone is more popular these days. All right, so let's go ahead and work on the demo. You can either follow along or by doing it, or you can just watch. I'll provide this GitHub repo and let me see in the chat, so you guys can fork it as needed. Cool. So let me start by sharing a different screen. Okay, so let me see if I'm still connected to my remote. Okay, looks like I am. Cool. You got page not found. Okay. Huh. So this is not working. I see. So maybe it's private. So this is IK's repo, but I also have my personal repo. So let me share that. That is public. So let's see. So it's both the same. So they both are synced. So you should pretty much see. In fact, I'm using the LectureBot repo as well. So yeah. So let me do this. Yeah. So let me open a new. Okay. So okay. So I'll go ahead and try to do this as much from the start as possible. All right. So let me clone this repo as well. So copy the git hash. All right. All right. So I have downloaded the repo on my local. So let me try to visualize this. All right. So so I have the folder in local. So maybe let's start with Readme. So it will give you some good information about the about the repo itself. What are the prerequisites, and what the goal of this chatbot is. Dependencies. All the dependencies are in the requirements.txt here, so which you can install with with the command provided in the README. And then to use the script, this is the command. So you can run Python main.py dash query with the question that you're trying to ask. So let's go through the actual repo, see how it's structured. So the key things here are, let's start with the Python files first. So we have transcribe classes, topics.py, summary.py, requirements, which is we just looked at all the different requirements that are needed to run this successfully, and main.py, where the main part of the code is located, and load docs. So we have these 5 Python files, or 6, 5 Python files. And then from a model perspective, so we have this model folder and class transcriptions folder, which has transcriptions. So let's go ahead and look at that. Now I'm going to switch back to my EC2, just so that it has the most latest run. So let me connect. Okay. So all right. So couple of other files which I downloaded here are, in the models folder, I downloaded the Llama 2 model, 13 billion model. So I downloaded here. I didn't check into the GitHub repo because it's like 8 gigs or something. And then other folder that you see new here is the, I believe, class VTT files. Let me see. Yeah, class VTT files. So it has a bunch of these VTT files. These are timestamp files. So let's take a look into one of these. So this is my starting point. So instead of video, I'm going with these, time transcription files that I can download from interview Kickstart portal. These classes are already transcribed by them, so I decided not to take the video and transcribe. So these are like bunch of time transcript files, like at each time what the speaker is talking. So that's how these files are organized. So first step is take these files and transcribe them using the WebVTT library. So let's see. All right, so I'm in the lecture bot. So first let me activate the environment. Okay. Okay, so first thing is to transcribe the files. So the transcribe classes.py essentially does that by reading the class transcriptions class VTT files directory. And for every file, if the respective transcription is not found in the class transcriptions directory, it creates one. So if you can see, I don't have transcriptions for all the files that are in the BTT files directory. So we can try to run this and see if it creates. And essentially, it's creating a cleaned up text version of these VTT files with the timestamps removed. And let's see, let's create this and see how it works. So you can see some logging output, that it's transcribing all these different files and it create all these new files in the class transcriptions. So let's take a look at one of these. So maybe, this one. Oh, sorry, that's a pickle file. So now the timestamps are all removed and it's a bunch of text, right? So that the speaker is talking. It's still like, very noisy. There is a lot of, words about how the speaker is talking. So it still needs a lot of messaging. So for these other files, I'm gonna go ahead and delete them. I'll tell you the reason why. Because the way the script is set up, we try to summarize them when running the question if those pickle files are not present. And summarizing each file is taking like, on this instance, it's taking like 40 minutes. So it will be a while if we start that right now. So I'm going to delete them for time being. So once the files are transcribed using the transcribe classes, so the next step is to go ahead and summarize them, chunk them, and store them in the vector store. So if you go back to the workflow, so here is where we are done with number one here, and we'll be doing number two, three, store it in the vector store, and then finally retrieve it and provide it through the prompt. So those are the next steps we are trying to achieve. So I'll keep this on for now. Okay, so for that, a lot of that logic exists in the main.py. So you can see a lot of these imports from Langchain, which is the runtime framework that we'll be using. And you'll see the quadrant client library and classes import from that. And prompt templates and different other functions and methods imported from Langchain framework. I'm also importing from some local functions from that I created in the summary topics and load docs .py. These are defined here. We'll talk about that in a little bit. So does anybody know what this is? Import pickle. What is it used for? Just curious. Yeah, so pickle is a library that can be used to serialize and deserialize files. So if you have Python objects that are created as part of the program, you can serialize them and store it on the disk. And that is exactly what we are doing. So we're taking this text file, creating summaries and other metadata and storing that into the pickle file, because creating those summaries and metadata takes a long time. We don't want to be doing it again and again. So that's why we are kind of, storing those objects as pickle files. So that's why we need the pickle import. And let me see what else. Yeah, so those are the main ones. Arg parse is essentially how to parse the arguments that you're providing to the input. Like when we submit the query, we want to be able to parse it and get the arguments and supply it to the commands, and other basic utility functions from OS and time. So those are the main imports. So and if you look at the flow of this code, so the first thing we are creating is creating a document class, so that we're also storing some metadata about the document, and the content is stored in the content part of the document. And within this metadata, we're storing both the summary and topics as well, which we'll look at in a bit. And then some functions to load the pickle files from the directory, or convert pickle data to document, and vice versa. So some functions related to that, custom functions. And these are the main parameters that I'm using for various parts of the program related to LLM. So token limit, like how many tokens you can submit to the prompt. For that, I'm using this number. Number of GPU layers. Again, these are based on the GPU instance that I'm using, but you need to fiddle with them based on what type of compute you have. Number of threads, and max tokens. The model path where the model is located. So it's located in models, this directory, right? And LLM path, quadrant, where the quadrant vector store is located. It's just under quadrant directory. So just providing the path to that. And supplying all that to the Llama CPP model. Llama CPP is the C++ implementation of Llama model, which we'll be using. And yeah, start with loading the docs that are in the pickle format. And if the pickle documents are not there, then it will go ahead and create them by calling these generate summary and generate topics functions. So let's take a quick look at what these mean, what these generate summary and what they're doing. So they're taking LLM as an input and the page content as input. So the first one is generate summary. So let's see what that is doing. So if you go to summary.py, you kind of see what's happening there. So the generate summary function. So first thing is it's taking the input text and breaking that down into chunks of size 500 with a chunk overlap of 50. So that's the process that is noted here. So the chunking process where you break a document and kind of split into multiple chunks and then process it. You can see it here as well. So essentially each splits is then summarized, and these summaries are concatenated together. And to summarize them, we are using LLM to summarize it. So we're using LLM chain function with the specific prompt here. The specific prompt is this. So here is a system input here for the LLM. And we're asking the LLM to summarize the below text from a class transcript. And then we're providing the actual text. So once we have this prompt template, we're providing that to the LLM chain along with the LLM that we have. And that starts creating summaries for each chunk and then appends all the summaries into a concatenated summary. So this summary is then added to the metadata of the original file. So that's the first part. So you take a so let me whiteboard this. So So you take a VTT file, transcribe it. Sorry, I think I'm not presenting the right window. All right, so you take a VTT file, you transcribe it. So that gives you a text file, and then summarize it. To summarize it, you first break down into chunks of 500 and summarize each chunk, and then concatenate all the summaries. So by this stage, you just have the summary of the entire text file. So the next step is to generate what are the key topics coming from this text file. So for that, we're using another LLM call, which is created in this topics.py. And essentially similar prompt. So all the previous summary that we are creating becomes the input here, and the LLM is also the input. And essentially, it creates the top 3 topics coming from the transcript and returns them. So after the summary is created, it's stored in the metadata summary, and the topics are also stored in the metadata topics. And we'll essentially create a pickle dump of this file into something like this. So going back to the flow. So once the summaries are created, the next step is topics, and then store it as pickle file. So that's one part of cleaning this document, creating the summaries and topics. And we still didn't get to creating any vectors or embeddings before storing in the vector store. That's the next step. So so for the next step, what we'll do is we'll use an embeddings model. Like I said, we'll use sentence transformers, all MPNet based too. For this, you don't need to download it. You can just use from the Hugging Face library. I believe I'm importing it somewhere. Yeah, Hugging Face embeddings. So that should have the this sentence transformer, and you can just call it with your data. So this this is more for model keyword arguments. These are for for the specific device type. We don't need those. I actually comment this out. But if you're running this on MacBook Pro, I think this is the right device type to use. So, and once you call the embeddings model, you can you can take the splits, and the next step is actually load the splits file that you created. And for splitting, we are using this recursive character text splitter. This is part of the Langchain ecosystem. So it actually goes ahead and splits the document into multiple splits of 500 tokens, and provides each split to the you can decide what the chunk size is. So based on that, it will split it, and it will create all the different splits, and uses each of those splits to call the embedding model, and stores those embedding models in the quadrant database. Here you're starting up the quadrant client. I'm using a collection called IK classes in the quadrant client, and just printing some time statements like when it started, when it ended, and essentially creating the schema. And force recreate equal to false means if the schema already exists, we're not going to recreate it, so that we're not, even if I run this again, it's not recreating it if it already exists. So just some optimization so that I can save the compute. So doing a bunch of stuff, storing these chunks and embeddings into the schema to be able to retrieve them later. So now the retriever part. So for the retriever, so we're using the quadrant retriever. Search type is MMR. We'll talk about that in a little bit. And search keywords k equal to 6, which means I want to return the top 6, fetch 50 and return the top 6. And we'll talk about what this lambda mult is also. So just going back to the flow. So once we have the pickle files, what we did was we loaded the embeddings model. Did the chunks, embedded with the loaded model, and then loaded the embeddings into vector store. So until this part, the entire storage part is done. Like, so the entire storing of the embeddings into vector store is done. The cleaning of the data, processing of the initial text files, and all of that. And so again, you can visualize this here, like, you're taking, this is actually a retrieval. So yeah. So now the next big part is retrieving it. So now that we have it in the vector store, we need to find a efficient way to retrieve it. So for that, we are using max. Sorry, give me one sec. Yeah, for that we'll use a optimization called maximum marginal relevance. So what that means is we're just not fetching based on similarity, but we are also fetching based on diversity. So the way MMR works is, so it doesn't, it makes sure that all the fetches based on the query have certain amount of diversity between them, not just super similar, like all the docs are exactly, very closely similar. So that gives some more, variety in the documents and summaries that can be presented to the user. So we can also configure this parameter through here. So this lambda mult is 0.3 is what is controlling that diversity. So if you want to make it super strict, you can make it something as 0, where you're only fetching very similar documents. If you want to make it very diverse and creative, you can increase that number close to 1. And based on that, it's fetching 50 chunks from the vector store, and then ranking them based on MMR and taking the top 6. The k equal to 6 parameter controls the top 6. That depends on the use case, Abhinaba. So it depends on, like, sometimes, in certain use cases, you want a lot of exploration, like, but maybe in educational learning topics, you want it more stricter. So 0.2 to 0.3 is very relevant. So that will still give you topics you might not have asked, while still giving you the option to, to be very close to strictness. So that depends on the chatbot you're trying to create. So now that we have a way to retrieve the relevant documents based on the query, we'll also create a prompt template. So the prompt template is this. It has a specific instruction, and giving some basic system instructions, and the context, which is the retrieved set of documents, and the question that the user actually asked. So all of that goes into the prompt template. And so with the input variables context in question. And I think one more thing I want to point out here is chain type equal to stuff. We'll talk about that in a bit. So so the way stuff documents works is, so all the user queries, and then we go retrieve top 6 chunks, right? So all these top 6 chunks are given to the prompt. So 6 docs plus query equal to answer. So LLM processes this with this context, and that's typical way you can set this up. So this method where you're giving all the documents at once is called stuff documents, and that's the setting we used because that's faster. And another more efficient or effective way is so you can do it as you pass the first document plus query, get an answer, pass this answer plus the second document, get answer 2, pass this answer 2 and the third document, and get answer 3, and so on and so forth. So you can do this in a chain fashion, which yields a bit better response and is fairly effective. But it also takes, the trade-off is it also takes a bit of time to pass it that way. But it yields better qualitative results. So that's another option where you can provide these documents to the prompt. So so those are the main settings, and then essentially once retrieve the result based on the prompt. For that we're using retrieval QA from the chain type, and it's again the whole settings are keywords or LLM is the language model which we are using. Chain type is stuff. Retriever is the retriever we defined earlier here, this one. So based on that, we'll get a result which will print out. So let's see how this works. So let's see if I'm in the right environment. Yeah, looks good. So I think I want to ask, what are the main topics in your architecture? Let's see. I think it's processing the documents to look for, to bring all those relevant documents from the vector store. So give it a second. In the meantime, let's go back and see what else I want to cover. So I'll pause there real quick. So we went through, the document storage flow. We went through the retrieval flow, looked at different settings that could impact, how you want to store these documents in the vector store, how you want to retrieve these documents and prompt these documents. So I want to give a quick pause and see if you have any questions. Let me see. Which EC2 instance? So I'm using G4DN, I think 12x large. So let me see. Yeah, so I'm using that instant type. It's fairly good. I think it's one of the It's one of the early versions of GPUs, but it's fairly decent. So just to give you a some sort of baseline here. So this document is just what each document is like 300 KB of text. It's a fairly decent document, maybe 4 hours of lecture, and it took me about 40 to 50 minutes to summarize and store this document into the vector store through all these LLM calls. So even with this, fairly powerful instance and a small size of data, that's the amount of time it took me. So that's why I only processed like three files here into pickle files. So in order to process all the other VTT files, it would take like a day or something. So so kind of makes you appreciate like how much work the modern LLMs are doing in the backend. So if you take for a baseline, like I think GPT-4 was trained for like I think more than 100 days on a big GPU farm, if I remember correctly. I think several tens of thousands of GPUs. So that's the kind of scale and the amount of time it takes to to even fine tune these models. So yeah, just to give you some baselines around that. All right, I think it's back with some answers here. So the main topics in neural architecture include feed-forward, convolution neural networks, recurrent neural networks, and autoencoders. So yeah, those are the ones that I actually covered in the class. So seems like fairly decent. And it took like I don't know what, little over 1 minute to come up with this response. So let's ask another question. What are salient what are the different kind of filters? Sorry, layers. Enhance. Let me see if there are any other questions. What are your thoughts on AI agents and crew AI? How would it relate it to RAG? I'm not familiar with crew AI. Let me Google it. Hmm. So are these like, next level of RPA, robotic process automation, I guess, where, you have multiple agents that can work with each other, kind of. So yeah, so you can think of like, RAG being one of those agents, right? So, or one of the backbones for those agents. So they could be using, RAG workflow for, for assisting some of these agents. So agents are essentially, some sort of, bots that can, take input and, produce output. So to do that, they're using some backend, like a RAG workflow or something else. So that's how they would come together, fit together, in my opinion. All right, good questions. Anything else? Any other questions while we are waiting on the output from the query? How is it known that which agent is to be selected by LLMs? There could be another model that actually does that, depending on the context. Like, we've done a very similar framework in, I believe, at Amazon. These are not agents, but to select which recommendations model for a given targeting strategy dynamically. So again, I think you could build models that that can actually do that specific purpose, like select the agent itself, and then the agent is its own model. No. The first call didn't create the summaries. The summaries were created long ago by me. To create summaries, like I said, it takes 40 minutes. So the call itself, even with this, since everything is local, this is not optimized workflow for sure. This is something I put together scrappily. So yeah, so just to query the vector store, come up with the set of documents, and prompt it, and call the LLM with that prompt and come up with the outcome. It's taking this long. I don't want to expose my private data LLM where we have to provide those configurations. So again, I gave multiple options there. Like one is, you can, like what I'm doing. I'm not sending any data outside my box, right? So everything is local. So I downloaded an open source LLM, and then I'm prompting with my private data. So no need to worry about data security in this case. Let's say you are using a open source LLM. I think there are ways to encrypt and decrypt data. So here is some answers. Different kinds of layers. Looks decent. Fully connected. It looks much better than the previous one actually. And then give some sample questions as well. Purpose of activation functions. Convolution and fully layer. So yeah, it looks like a decent output here. Cool. So yeah, going back to privacy. So one is you can control the whole thing by bring this into your own ecosystem, like the LLM and the whole entire RAG flow, like on your in your ecosystem, like how I'm doing it. The other way is, I think you can still encrypt the RAG documents and decrypt them. So that could provide some sort of some sort of security for data in transport. Let me think. Yeah, I can't think of anything else at the moment, but yeah. Cool, good questions. Yeah, good question, Sarkan. So I kind of alluded to that in the one of the slides. So how do we choose between RAG versus fine tuning? So depending on the use case, like and most modern LLMs that are available through open source are are trained on massive amounts of generic data. So you can and they have very good semantic understanding of the the language. And to fine tune that model, now you're trying to fine tune trillions of parameters, if not billions. So one, do you have that capability as a company? Because it costs like millions of dollars to do that. So if you don't, then then maybe see if you can just use a RAG workflow and create very focused prompts and prompt templates. So you can get benefit out of existing LLMs and providing them with specific data. That's a very viable approach that's being used by a lot of companies. The major reason I would think of fine tuning it is, if your data is very domain specific and regular language understanding does not apply, which is very rare use cases. I haven't seen one yet. Like, I don't know. Maybe like it's a very specific in medical use case, but even for medical, there are medical LLMs that you can start with. So, so it all depends on the use case and how specific it is, how niche it is. And if RAG is not giving you proper results, then yeah, fine tuning is probably the next best approach. Yeah, LoRa is good for low rank adaptation, and there is QLoRa as well. So those are techniques that can reduce the model size, prune it, and optimize the model. So it's not having as many parameters or as much size. But even with all of that, you're talking like models of several billion parameters. So this one that we loaded is 13 billion parameters, right? It's an 8 GB model. So it helps definitely in fine tuning, but even with all of that, it takes like a lot of power and compute to be able to fine tune. Cool. So let's go through last couple of slides. I think we went through this. Yeah, just quick overview about the Gen AI course at IK. So here is the high level overview. So you have the first 2 weeks on Python, and 4 weeks on hands-on with Gen AI, like the background neural networks, diving deep into. Sorry, I'm not presenting the right slide. Yeah. So first 2 weeks of Python crash course, 4 weeks on the Gen AI aspect, like some background and underpinnings of Gen AI. A lot of things that we looked at, like background into neural networks, LLMs, and then more of application building for the next 4 weeks, like training LLMs, across different modalities, images, audio, text, or building RAG workflows, and so on and so forth. And then there are offshoots to different pathways, like towards product manager pathway, towards software engineer pathway, or managerial pathway, where um, there is very specific classes geared towards those specific fields and roles. So this course in general is not geared towards one specific role. Any roles can benefit, given the importance of Gen AI knowledge in modern workforce. So yeah, it's kind of more generic towards both engineers, engineering managers, product managers, QAMs, or even like program managers. So a lot of different roles can benefit from this course, because it doesn't need like in-depth knowledge, but it gives the knowledge needed to go build a Gen AI application or oversee the development of a Gen AI application. Yeah, just quick overview, like a lot of the modern recent job postings have like Gen AI in their descriptions, like using LLMs and stuff like that. So just give a quick overview, like how much the companies are looking for these kind of tech stacks, and the roles that they're posting. Again, it's geared towards all kinds of different roles, like I said. So anybody can benefit from this course. Um, yeah, so that's a quick short pitch about the course, but you can get more details from the IK team. So you can just email them if you need more details about the course. So yeah, I'll be open to any questions. Um, as far as I understand, this course is not for interviewing. So you mean to ask like, does it just prepare you for an interview, or does it prepare you for um, more knowledge in the Gen AI space so that you can interview for those roles? I didn't understand the question. Um, so yeah, so one thing to note is like, in the coursework, let's see, is um, the course is not going to teach you like, how to go build an LLM from scratch, or it's more of application of these ML and how to, create these all these workflows that are very useful um, in enterprises these days, like fine tuning an LLM, or taking an existing LLM and building a RAG workflow, or prompt engineering, or chain of thought prompting, like building on top of LLMs. But it's not about like understanding the core basics of transformers or neural networks, or how to go build a GPT class of models. So that's the distinction. So it's more of an application oriented kind of course. For that, you need some fundamentals, right? So with respect to Python, so that's what's going to be covered in the first 2 weeks, and then some basics around the Gen AI itself, like how the different um, technologies in the tech stack of Gen AI work, and then more of hands-on work. Akila, Maria John, RAG versus prompt engineering. So prompt engineering can only get you to the point where you have um, that specific data in the LLM, right? So if the LLM doesn't have the data, and you need to use like very specific data, then no matter how much you engineer the prompt, it won't get you that answer. So that's when you need, whenever you have this specific private data that you want to utilize, that's when RAG workflows help. All right. Happy to stay over for a little bit and answer any questions. Awesome. Glad to help. Thanks for attending, everybody. Feel free to connect on LinkedIn or otherwise. If you have any further questions on the course itself, IK team is the best person to answer. And happy grokking Gen AI. Let me post my LinkedIn in the chat window here. I am not sure about the recording. That's a very good question. So maybe I think you can get a recording. Ask IK team. Send a message. Yeah, I think I got a message from IK team that you can ask for recording. So yeah, you can just reach out to them. Right. There is nothing else. I'm going to close the session. Good luck, everybody. Have a good rest of the weekend. So yeah, thanks for attending.